this video, I'm going to talk about our third duopoly model, the Bertrand competition. So here are the model-specific assumptions, and then I'm going to talk about a problem-specific assumption, and then solve a numerical example. The solution is actually pretty straightforward. Well, I mean, not pretty straightforward, but sort of the solution is very simple, but you know, the model is not that straightforward. So let me just go through the model and then why this model leads to that solution. So here's the model-specific assumptions. There are two firms, firm 1 and firm 2. They choose prices, not quantities. All right, and the prices can be 0 or some positive number. The prices can never be negative, right? What is the point of, I mean, there's no negative price. Cannot be infinite. Infinite is not a number. So each firm is going to choose price. Each firm has a cost function. A cost function depends on how much quantity the firm produces. And then there's a demand curve, all right? Well, this time I didn't write the inverse demand curve. Well, you'll see why. So there's a demand curve, and then the demand depends on the market price, P, but the market price is going to be determined by the players, all right, by the firms. Well, the timeline, it's simultaneous, but here's how the game proceeds. Firm 1 and firm 2 simultaneously and independently choose their prices, P1 and P2, all right, P1 and P2. Well, then that's it. That's the end of the game. What happens is that the lowest price will get the whole customer. So the two firms are competing over the price, means that, well, they choose their prices simultaneously and they post their prices. The consumers can observe both prices and they will always choose the seller with the lowest price. All right. So even if the price is 1 cent or, I don't know, a fraction of 1 cent less than the other firm, all the customer will go to the lowest price. That's an assumption. All right. That's an important assumption. The lowest price gets the whole demand. All right. So therefore, the market price is going to be that market price P is going to be the minimum of P1 and P2, all right? So both firms will simultaneously post their prices. That's going to be it for the firms, but the outcome will be determined by the lowest, you know, how those prices are relative to each other. So if P1 is less than P2, firm 1's price will be the market price. Firm 1 will serve the entire market, and firm 2 will basically serve to no one. All right, so it's 0 customers because it's the expensive firm. If P2 is lower than P1, this time firm 2 is going to serve the entire market. And then firm 1 is going to get 0 demand. All right, but P is going to be the minimum of those prices. Well, if this is a without loss of generality assumption, it really doesn't play an important role. If it happens that the firm 1 and firm 2's prices are the same, what is the final price? Well, then again, the final price, well, because the prices are the same, either one is going to be the market price. Well, how are they going to split the market? Well, let's say the firms split the market 50-50 because both firms charge the same price. Half of the customers go to firm 1, half of the customers go to firm 2, let's suppose. Okay? And then the total demand will be determined by the quantity P, the demand curve, right? So the firm 1, when I say the firm 1, for example, P1 is less than P2, firm 1 is going to win in a sense, meaning firm 2 is the expensive firm. So everyone will buy from firm 1, but how much quantity will be demanded? Well, it's going to be determined by the demand curve Q of D, okay? Q of P1. So basically that's it. That's the model. Well, here, this problem is in fact a little complicated if you dive into details, partly because the profit function of the firms is not a continuous function. But that's okay. The solution is nevertheless pretty simple, at least for some cases where the marginal costs are the same. So profit of firm 1 is going to be a step function. All right? So there are going to be three important parameters. I'm sorry, two important parameters and three cases. So what if price of firm 1 is less than price of firm 2? What if the prices are equal? And what if price of firm 1 is greater than price of firm 2? All right? Well, I am looking for the profit function for firm 1, so what matters is the P1 relative to P2. So, according to the rules of the game, if the firm 1 is charging higher price than firm 2, no one is going to buy from firm 1. All the customer will go to firm 2. Therefore, the quantity demand for firm 1 is 0, and so the firm 1 shouldn't produce, and its profit will be 0. Okay? So that's the simple case. If. Well, what if the prices are the same? Again, according to the rules, they're going to split the demand equally. So let's call this P, all right? So therefore, the quantity demand will be Q of P times, this is how much demand will be, times the price. This is how much demand firm 1 will get, times the price. So this is revenue minus the cost. C1 QP divided by 2. So this is the Q1, all right? And the cost, all right? That's it. Well, what if P1 is less than P2? So firm 1 is charging less than firm 2. In this case, firm 2 will serve no one. Firm 1 will be monopolist in a sense. So it will serve the entire market. I mean, the demand will be Q of P1, all right, times P1, so this is revenue, minus C1 Q of P1, all right? So that's the cost function. Well, what about the profit function firm 2? Exactly symmetric, all right? So the profit function for firm 2 is going to be, 0 if P1 is less than P2, right? Meaning firm 2 is the one charges higher price, so therefore it should get no customers. Exactly the same, Q of P times P divided by 2 minus cost of producing this many quantity. So this is Q2. If P1 equals P2, and let's call that as P, the price. And then finally, it's going to serve to the entire market, Q of P2 times P2 minus C2 Q of P2 is how much quantity it will produce if P1 is greater than P2. All right, so the firm 1 is, no one is going to buy from firm 1. So that would be the profit function. All right, so the profit functions are not continuous. Therefore, they're not differentiable. So finding reaction function is complicated business, yes. But luckily, we don't need to calculate the best response function or best reply functions or anything in this problem. So the question is, what is the Bertrand outcome? Well, for this, we are going to make a simplification assumption, and we're going to assume that cost of firm 1 of Q equals cost of firm 2, which is equal to sum C times Q. All right, meaning both firms have, firms have no fixed cost, 0 fixed cost, and both firms have the same marginal cost, which is equal to C, some, non-negative number. All right, so that's the cost function. The marginal cost is fixed. Okay, so the question is, what is the Bertrand optimal pricing, P1 star, P2 star? Well, the solution is simple. P1 star equals P2 star, which is equal to the cost, the marginal cost. That is the only solution in the Bertrand competition. All right, so both firms are going to charge the same price, and both firms will charge the marginal cost, which is like the perfectly competitive market price. which means the firms are going to make zero profit, right? If you're charging your marginal cost, your profit will be zero. Well, the question is, why is that so? Well, again, the solution concept we use is, in fact, the Nash solution here. And again, the idea of Nash is the following. Once the prices are revealed, to the buyers, the sellers are not going to regret. They're not going to say, oh, shit, I should have charged lower or higher. So it's going to be a regret-free outcome. And both firms charging the marginal cost is the only regret-free outcome in the Bertrand model with the same marginal costs. You may ask, what if the marginal costs are different? Well, then the problem becomes significantly more complicated. So for that reason, I'm going to skip that model for this course. All right? What if there's a fixed cost? Again, I'm going to skip that for this course. So let me explain why this is the only Nash equilibrium or only outcome. Well, think of something else. Is, for example, firm 1 charging P1 equals, let's say, by the way, here that's an important assumption. I mean, maybe I should just underline. Any prices are possible. So in reality, the prices can go with cents, right? 1 cent, 2 cent, 3 cent. You cannot, for example, charge a $1.58.5, and there's no such price. But in this model, for simplification, because once we make things discrete, the entire model becomes even more complicated. So for simplicity reasons, we assume that any real number between 0 and infinity can be a price. So obviously infinity is never a number, but it can go up to infinity. So 0 is here. So let's say the marginal cost is here. All right. So the firms will charge a price somewhere in this range. First of all, the firms will never charge a price lower than the marginal cost. Well, I don't know if you remember the arguments in in the first intermediate microeconomics course, but the profit of a firm is always price minus marginal, price minus marginal cost times quantity if there is no fixed cost, all right? So price times quantity is the revenue, marginal cost times quantity is the, so if this is a fixed marginal cost, okay, I'm sorry, if it is a fixed marginal cost, well then the marginal cost times quantity is the cost. There's no fixed cost, and the marginal cost is a constant. So therefore, P minus MC times Q is the profit. So if P is equal to your marginal cost or lower, if it is equal, the profit is 0. If your price is lower than the marginal cost, you're going to suffer loss. So therefore, getting 0 profit is always the option. So you should never charge a price lower than marginal cost. Never, ever. So it's never optimal to charge a price below the marginal cost. So at least, not at least, sort of the boundary is the C. You can go above that though, right? So let's say P1 equals P2 equals this P level. All right, so something above C, but they're the same. I mean, why? They can be different. I'll discuss that. So let's suppose they are the same. Both firms are charging the same prices, which is equal to P higher than the marginal cost. What's going to happen? Well, if you look at the profit function, the firms, because the prices are the same, the firms are going to split the demand equally. All right? So what happens is that if demand is a nice function, all right, well, you don't actually want to split. So by the way, here the marginal costs are also simpler, right? So this is C times QP divided by 2. So this is also C times QP divided, just QP1. And that's 0. So the marginal cost is 0. I'm sorry. So let's simplify that. So if the prices are the same but above the marginal cost, what happens is that you're splitting the demand. But if you charge slightly lower, all right? Very slightly lower than your opponent's price. So your opponent is charging P dollars, all right? But you would like to charge lower than this. I don't know, 1 cent or even less than that. What's going to happen is that you're going to get all the customers rather than half the customers. All right? So will that increase your profit? Of course. I mean, imagine. So this QP is, I don't know what it is, but it's some positive number, 100, let's say. So you're basically splitting 150 customers is coming to you if you charge exactly the same price. But if you slightly price undercut, so this is not P, but it's very close to P, like P minus, I don't know, 0.0001. So what happens is that you're going to get 100 of those customers, maybe not 100 because the price is now lower. You're going to get, in fact, 101, all right? So this is going to be higher than this. So obviously that the cost will be higher, but the thing is, this profit is going to be higher than this profit simply because of the marginal cost, right? I mean, it's like P1 minus C versus P minus C times Q over 2. Here it's Q. So P minus C is almost the same because this is just slightly lower than this. However, Q versus Q over 2, here I have 50 customers, here I have 100 customers. Clearly, this is a huge number change here. Very small difference here. So this has to be bigger than this. All right? So what does that mean? That means if my opponent and I charge some price P higher than the marginal cost, I'm going to regret that once the prices are revealed. Remember, the solution, the Nash solution, is always a regret-free solution. So why would I regret? Well, because I'm going to say, oh, I should have price undercut my opponent. Price undercut my opponent. So therefore, P1 equals P2, which is equal to some P that's higher than C, will never be an outcome. Well, okay, but what about the case where, for instance, P1 is here, P2 is here, and they're different, and then they're higher than C? Well, here, the P1 guy, the firm one, is actually making 0 profit. So clearly, once those prices are revealed, firm 1 is going to regret that choice, and it's going to say, oh, I should have price undercut my opponent, so slightly lower than P2, and hence get the old demand rather than 0. All right? And it's going to be positive because P2 is already higher than C, so there's definitely a price which is higher than my marginal cost, so I can make a positive profit rather than 0 profit. So this is not regret-free outcome. So therefore, that means the firms have incentive to price undercut each other. All right? So they will never set the prices equal. One will always want to go below the other. But one is higher, the other is lower, will never be an outcome because the higher one always regret and would like to price undercut the lower one. And so the prices will go all the way down to where, remember, they can never go below C. So they're going to basically go all the way down to P1 equals P2, which is equal to C. Once this is the price, is this regret-free? That part is important. Yes, it is. Why? Well, because the firm one, let's suppose, has no incentive to price undercut its opponent. Why? Well, because if firm one charges price lower than C, it's going to get the whole market, but P1 minus C is going to be negative because P1 is less than C. So therefore, no firm has incentive to price undercut. Well, what about charging a price higher than your opponent? Well, if you charge a price higher, you will automatically get no demand, right? So you're not going to sell anything. So your profit will still be 0. So it's not going to improve your profit, all right? So 0 and 0. Well, you know what? Therefore, I am not going to regret as a firm 1 or firm 2. I'm not going to regret if these are the prices and if those prices are revealed to the customers. So therefore, this is the Bertrand solution in the simpler model where the marginal costs are the same and there's no fixed cost. As I said, if the marginal costs are different or if the prices are discrete, well, then the game slightly changes, but the outcome significantly changes. So I'll skip those extras for this course. Just stick to this basic. All right. So if the marginal costs are the same, the Bertrand solution is such that both firms will lower their prices all the way to the marginal cost, and so the firms will charge perfectly competitive market price, which is the marginal cost. Hope that was clear.